Yeah, we're gonna pick up the tempo maybe a little bit, but I also want to encourage any questions. And once again, remember I have two screens here, so I'll open my chat window over here. That's my let me open up my chat window, but that's on my second screen here. So if you do have a question, you can either type in the chat, and if I don't see it, maybe Ralph can then
Prompt you.
tell me that that it's there. So and I'll occasionally glance over. So. Um, So let's, we finished up, we were talking about second generation. We're going through the different generations now, just kind of seeing what are the highlights of each generation. And so we finished off, let me go to the slide where we were just about right around here. We're
Yes.
talking about the second generation systems. And one of the things, just remember, in a GSM, which was the predominant second generation, GSM, it's a French acronym, but they made it more English with Global System for Mobile Communications. But it was a standard. That's a key thing to remember, that the inside the handset, which was your mobile equipment, and your SIM card, that became what's known as your user equipment. It was a standard radio interface. It was frequency division multiple access, so you had different frequencies, but also you were divided up into the time domain. So you could share it with up to 8 other users. It was time slots 0 to 7. They were very short. They were like 4 milliseconds, very short time slots. But as you're speaking, someone else could speak at that basically the same time, but you're assigned these different time slots. So this was all standardized. The communication between this radio, and the radio was broken up into the base transceiver station and the base station controllers. And that communication back to the central switch, that was a standard protocol. And then it's called the BSSAP, base station subsystem application part. And then the communication between the mobile switch and all of these registers and databases that are needed for mobility, that was a common protocol. That was kind of, they used SS7, and the application was called GSM map, mobile application part. Whereas other second generation systems did not follow that strict of a standard. They had looser standards on the air interface, like over here. They had looser standards on the communication back to the central switch. So that was very important. So when you look at the high-level architecture, it's made up of these piece parts. We looked at this last week. So the switch had these internal databases and registers that it would talk to, and that was for the purpose of mobility. But it would also talk to other networks. It would talk to wireline networks, which is called the public switched telephone network. It would talk to other mobile network operators, MNOs, and these were voice pads or trunks, so you could pick up your phone and talk to someone that way. And this was what each piece part did in the mobile network. Now we don't have to go over each piece of this. You can read it in your manual, in your book. But basically, these are all the parts. Your mobile station. This is all considered your radio access network, and these cell towers were called base transceiver stations, and they would communicate with a controller. And the controller would manage the radio and the handovers, and that would connect back to the mobile switch. And there were multiple base station controllers and multiple base transceivers. You can imagine there's hundreds of these cells out there. And these are the registers, the databases. The visitor register, which temporarily stores your subscriber information, your home system, which is your permanent subscription database, authentication center, which is what it says, it authenticates the mobile. This stores a list of your equipment identities, your international mobile equipment IDs. And this is your message center. If someone taps out a short message, it goes to their home message center, and then it goes to find the recipient. So this was the non-roaming architecture. So the architecture which this just described everything, and this was the architecture when you were not roaming, where you're in your home network. So you're basically connected through the radio, through the controllers, and you have access into the mobile switch. You can talk to your friends and on the networks, and these devices here help or assist in managing the mobile.
So
When you're talking, yeah, please go ahead.
yeah. So this is the second generation architecture, right?
This is second generation, yes, and that's going to lead us right into the third generation, because the third generation did not change a lot here. Yes, this is considered second, and there is still second generation around today. So there are many networks that still use second generation GSM.
Okay. Okay. Thanks.
Okay, sure, absolutely. So when you're roaming, you need to connect up. You need to connect these networks together because a visited system needs to get information from a home system. So if your home system is in this upper right-hand corner right here, and you get on an airplane and you fly over here, now there has to be roaming agreements in place. And there's a lot of commercial things that have to happen. But from a technical point of view, this network that you're visiting over here on the left-hand side, it needs information from your home system. Who are you? What do you subscribe to? Do you have any restrictions and any all this other information? So it has to go find you, and it does that through SS7, through the signaling network. It'll go through these devices. These are called signaling transfer points. These are routers. These are routers just like an IP router. These route SS7 messages. So it will go through these various networks, and it will go to your home system, and it'll ask the home system for certain information. And that certain information then over SS7, using SS7 protocol, will then go here, and now the visited system will know something about it. So, and that protocol and second generation and third generation mobile phones, that protocol, that the structure was signaling system 7 or SS7. Now, in the mid-1990s, something else happened. Mobile phones were just beginning to be used for data. Now, this wasn't high-speed data. This was not video. This was not movies or anything else. This would have been low-speed data, things like Word documents, maybe emails, things like that. But it was data. The time division multiple access is not efficient for data loading data. For your voice, it is. It's relatively efficient for voice. But for data, when you're downloading data, you want that data to be downloaded relatively quickly. You don't want to have a time slot and then wait 7 more time slots for the next piece of that data to come, then wait to have 7 more time slots for the next piece of the data. What would be more efficient is if you're using your phone for data, is to grab all kinds of idle time slots and use those and put the data in all of those. Once you've downloaded that document and that document is on your phone and you can read it, then you can release those facilities, those time slots that are in the TDMA structure. And that's what is called, and this is kind of a strange name, called General Packet Radio Service, GPRS. This came about in the late 1990s. And that introduced this packet control unit here. It introduced 2 new devices here that access the packet network. One was called the Serving GPRS Support Node, or the SGSN. Another was called the Gateway GPRS, General Packet Radio Service Support Node. And that is how you would access the packet network. Let's say, well, at this time, the internet was there. It was relatively new back in the late 90s. It was there, but it was still relatively new. So now this device had the ability to through this packet control unit, instead of you having just one time slot, and you would have just one time slot if you're using the system for a voice. If you're talking to someone for a voice, you have one time slot out here. But if you're using your mobile phone to download a data, let's say an email or a document, something, again, no video, nothing that high speed, then through the packet network, this packet control unit would now assign you a lot of time slots, all these vacant time slots, so you could then download that document very quickly. Once you downloaded it, it would release those for others to use. That was the whole idea behind General Packet Radio Service, GPRS. So it introduced this SGSN, Serving GPRS Support Node, and Gateway GPRS Support Node, and this interface from this packet control unit. Now the radio looks a little bit more. There's a little bit more to it. You have a base station controller, which is controlling your voice. You have a packet control unit, which is controlling the data side of this. So GPRS, and this is just, again, a little bit what each one of these units did. This device here, this Serving GPRS Support Node, talked SS7. So it had to know where you were at. It still had to do authentication and billing and it routed packets. So it still had to communicate, and it did that over SS7. This was a separate protocol. The packet control unit would talk to this serving GPRS support node right here with a separate what's called base station subsystem generic protocol, GP. This was a brand new protocol here now. This was called GTP, GPRS tunneling protocol. What that is think of it as a pipe or a tunnel, and your data packets would go inside that tunnel. It's kind of like how a VPN works today. It surrounds your data packet with another packet. It routes it on this outer packet, but yet inside there's another packet. It's like me writing a letter to you, and I address the letter and put it in an envelope, and the envelope has your address and my return address. Then I take that envelope and I put it inside another envelope, a FedEx envelope, and I mail it to you via FedEx. So I've got an envelope inside and an outer envelope. That's what these tunneling protocols do. So that was on this interface right here. It's called GTP, which is GPRS tunneling protocol. We'll talk more about that. That was very new here. It became more predominant in 3G. It became very predominant in 4G. 4G has tunneling protocols all over it. So for non-roaming, it would look like this. You would still communicate here. You had a base station. That should be BSC, base station controller. The C is missing there, it looks like, or it's not stretched out enough. Let me just see if that is a BSC. Yeah, that thing is somehow didn't get, there it goes. It got lost there. We're gonna need the BSC.
Yes.
Correct that. So that's the base station controller. You have your packet unit. If this subscriber is using their phone to talk to their friends, this is the path you take. Air interface through the base station controller, and then the mobile switch, then you communicate with the world. Your mobility management was done here. If you're using your phone though for packet, the base station controller connects up with this packet control unit, and that uses that BSS protocol, and then it sets up a tunnel. And that tunnel then accesses through the home exchange here to your home network. So this is in the case of roaming now. Yeah, this would be the non-roaming. This is the roaming piece. One of the things about data, and this is very predominant in mobile communications. Whenever you use your phone for voice services, let's say you're roaming somewhere. Just imagine you get on a plane, you go somewhere else, you're on another network, and there's roaming agreements. You power your mobile phone on, and if you call someone, you're using the facilities of that network where you're at. Let's say you fly to Dublin, Ireland, you're using those facilities. However, if you're in Dublin and you want to go www something, you are home routed. In other words, that tunnel, that data tunnel, that GTP, GPRS tunneling protocol, gets set up from the serving system. That tunnel goes all the way back to the home system. And your home system monitors your data. Your home system, now, could you do it the other way? Could you actually have your data access from the visited network in Dublin? Yeah, technically, of course, you could. But from a practical point of view, or from a commercial point of view, home systems always want to know what you're doing for data. So they build these data tunnels. When you register on the system and do an update location and power on, that data tunnel gets set up all the way through what's known as the GPRS exchange. That's just a series of networks that connect up and build this tunnel, this pipe, this GTP, GPRS tunneling protocol, which gets set to this gateway GPRS support node. And then you access the packet network from the home system. So again, this is your home network in Accra. You fly over to Dublin, you use your phone to call someone, you're going to use the local network. You do www anything, you're going to go through here and go get tunneled back to Accra. That's called home routing.
So question,
It's kind of an important concept too.
So question.
Sure.
Yeah. So you mentioned that the home, whatever they need the data that you use. Why is that so? Like they always need
Your home network, I mean,
your
your home network always monitors the amount of data you use. They want to know a lot of things about this. They want to know what kind of, it's their way of knowing what you're doing data-wise. I mean, you certainly could, if you access a data network from your visited system from Dublin, that's called local breakout. Then this device here would be right here, and you'd access the data network there. And you could do that. But most networks, if not all networks, I'm going to say 95 to 98% of all networks route data back home. So when you do www, even if you're searching for a restaurant in Dublin, you go back to your home network, because your home network monitors that. It monitors the data. When you access data, it knows what you're doing.
So in this case, how does it benefit them? Because storing this data actually takes a whole amount of storage. So
yeah, but it's just like, okay, sure, but remember, this tunnel is just built up. This is just a data tunnel.
Okay.
And the data packets come from the mobile. You do www, weather or something.com. Well, that's just packets that sends that over to this gateway GPS support node, and it just goes out to the internet. So you access the internet from the home system, even though you're roaming somewhere.
I think it makes sense.
Okay, good. Yeah, it's kind of it's a concept. You have to just kind of again, now you could, if you access it from the visit network, that's called local breakout. If you're in your home network, then it's local breakout. When you're at home, your serving GPRS support node and your gateway GPRS support node are both in the same network. Okay. So that's called local breakout.
So
when you're roaming,
Raymond,
it's called home routed.
Okay. I think Raymond wants to speak up.
Yes.
If that is so, Raymond.
Yes, I didn't really understand the difference between the SGSN and the GGSN.
Okay, let's go back one slide. The serving GPRS support node, that's kind of the interconnection point between the gateway and think of this as the kind of the intermediate point between the gateway and the radio network here. So this is responsible for routing, for authentication. All of your charging, all of your billing is done here. This is your access into the world. When you have data, you need an IP address. That IP address gets assigned by this device right here. And this tunnel gets set up right here. And ultimately, protocol is going to go this way too. So this thing, if you move and move and move and move, you can keep the same IP address because your IP address is assigned by this device, even if you have different data tunnels there. So the gateway GPRS support node, this device here is just responsible for, it's your gateway to your external network. It assigns your IP packet, and it's your access into the packet network. This is just kind of it's the device that does your mobility management. It's the device that does your authentication. They both work together, but think of this as think of this as a pipe, kind of a pipe between those two, and your data is going to go inside that pipe, kind of like a water pipe or something like that. But this is what each one does. Managing the session, managing the mobile, routing the packets, doing your authentication, charging, all that is going to be done by the SGSN, the serving GPRS support node. And the gateway is the kind of the final point into the world. Okay? Make sense? Okay, yeah. Excellent.
Yeah, thank you.
Sure, absolutely. Now, it's getting to be the turn of the century. it's now late 90s. We not only have a new century, we have a new millennium. We have a new everything. This is 1999, and things are moving. Well, there was motivations to upgrade to another generation, and that generation was called UMTS, Universal Mobile Telecommunications Service. Okay, UMTS. And what was the reason for it? Well, there's an increased, the mobile phones were getting more intelligent and better memory capacity. GSM was designed as a voice, but consumers were using their phone. They're beginning to use their phones for more than just voice. More and more data, again, slow data, don't think of it as, there's not video yet. That's not until really 4G. But there was a lot more, people were starting to use their mobile phones for downloading emails and downloading documents, and just, again, more and more data as time went on. Need for more capacity, the need for better battery life. So 3G was designed really for this. Now, one thing we got to kind of understand that during the 1980s, no one called mobile phone 1G or first generation. Throughout the 90s, no one called GSM second generation. It wasn't until this came out that they went back and renamed the 1990s GSM, the second generation, and then the first generation. So this was the first generation where they kind of renamed everything. They said, okay, now this is going to be a third generation. We're into a new decade, we're into a new century, we're into a new millennium, and we're going to call ourselves 3G. So it maintained the same basic network, except the air interface became wideband CDMA. Over in the Americas, they were using narrowband CDMA. Remember, that's the 1.25 megahertz, kind of a big channel. And this is where you're assigned a code. So everyone's talking on that same frequency, but the mobile and the cell tower are only looking at the code that's been assigned to you and the code that the radio has for your particular mobile that the cell tower has. So that CDMA, that's in North America, that was called narrowband, 1.25 megahertz. This was wideband CDMA phone. Wideband was a complete thought. Wideband was a big 5 megahertz. It was a huge amount of frequency called wideband CDMA. But the architecture in the network stayed virtually the same. So 3G, the biggest change in 3G was that the air interface went from time division multiple access to a wideband CDMA. Something else very critical happened, and right about the same time in late 1999, when 3G came out technically in 1999. The standards that were being written primarily by ETSI, European Telecom Standards Institute. They wrote all the GSM standards, they wrote all the GPRS standards. ETSI, along with these other groups here, right? See where it says ATIS, ATIS, ETSI, this group, this group, this group, this group. These 1, 2, 3, 4, 5, 6, these 7 standards groups formed what's known as 3GPP, Third Generation Partnership Project. And they write the standards for these things: radio access, core network, service capabilities, coders, decoders, security, quality of service. Literally hundreds and hundreds and hundreds and hundreds of specifications that cover all of this. That's 3GPP. There was another group called 3GPP2.
It was, I think,
that was
a
formed
trial.
with these groups.
You have to try some code.
What's that?
Sorry, not with you. Sorry for the interruption.
Okay. So you had 2 different standards groups. You had 3GPP with the numeral 2, which was kind of following the second generation to third generation standards that were in North America primarily. And then you had 3GPP, Third Generation Partnership Project. That was the GSM. And now GSM went to 3G. So you had two different standards groups. So again, now this one today is defunct. Today, the only mobile communication one, basically the only one in the world is third generation partnership project, even though that's the same group that writes fourth generation standards and fifth generation standards, called themselves 3GPP, almost like they jumped the gun, like no one was expecting there to be a fourth and a fifth generation. But anyway, that's what it is. So the standard today in mobile telecommunications, as far as your radio standards, your core network standards, all of your capabilities, your coders, your security, quality, all these things are written by this group right here, which is called 3GPP. And you can go out to www.3gpp.com, it's .org for sure, .org, and you can download one of those standards. We'll do that a little bit later. So you now at this point in time, you had two different groups that were doing 3G. One that followed the GSM standard, that's this one right here, and one that followed what was at that time North American CDMA, narrowband code division multiple access. So the second generation on this top one for that was written by 3GPP was called GSM. Their third generation was called UMTS, which is this one right here, Universal Mobile Telecommunications Service. The radio interface was wideband CDMA. Now there was one country, I believe China, I think that's the only one that had time division. That's synchronous CDMA. I don't know what that was all about. That's a narrower wideband CDMA, but this was predominant in the world, wideband CDMA. As time went on, it was kind of enhanced and went faster and faster and faster with these technologies. We don't have to worry about these now. This is high-speed data packet high-speed downlink packet access, high-speed uplink packet access. That's just as time went on. Before it became 4G, it became quicker and quicker. Now some networks, some networks were CDMA in the second generation. They became what's known as CDMA 2000 for 3G. They kept that narrow band code division multiple access, which was 1.25. That was the narrower code division, whereas GSM was that wideband CDMA, this one right here. And again, this is just some other enhancements to it. There was another network out there that was written by the IEEE, and that was called WiMAX. Again, we don't have to go into that, but WiMAX was just another technology. So at this point in time, there were basically three different 3G technologies. The one that dominated, was this one. This GSM dominated, and ultimately, these all went away. This went away, this went away. How are we doing? Let's take a look at just this general architecture, and then we'll call it a day today, I think. So the overall architecture is basically the same as it was for 2.5G. So just what we looked at earlier with DPRS, General Packet Radio Service, basically the same architecture. A couple differences. Number one, your air interface now, instead of time division multiple access, is now right here, this wideband CDMA. That's a big difference. Another big difference is right here. You didn't have those two base station controllers. Now you had one radio network controller. That was the second biggest difference. You had one radio network controller. Whereas on 2.5G, I'm gonna go back a couple slides, 2.5G, you had this. You had the second generation base station controller, and you had this new packet control unit. Well, now these get combined in 3G. They get combined into this right here, the RNC. The other big change, that's two big changes, air interface, radio network controller. Another big interface is this interface right here. That is now GTP. So now you have a pipe right here, a tunnel here, and a tunnel here. And your data packets would go like this. Your data packets would go through here, through that tunnel, out to the packet network. If you're using your mobile for voice, air interface, radio network controller, the IU circuit switched interface to the mobile switch to the world. So now your mobile can do circuit switched for voice and SMS. Short message service is still circuit switched. But if you're using your mobile phone, which more and more people are using their mobile phone for data. Now again, I want to emphasize, keep in mind the time frame. This is 1999, 2000, 2001. The iPhone is still 6 years away. The iPhone wasn't introduced until 2007, 2008. So this is 5 and 6 years before there were smartphones, but just not the amount of data that we know today. Questions?
Hello. Yeah, Steve.
Sure.
Yeah, so with the iPhone, before the introduction of the iPhone, so was it this which company was predominant in the mobile industry before the introduction of the iPhone in terms of accessing data?
You mean I'm not sure I understood the question. You mean what kind of data were people using this for?
No, I mean the device per se. Yes.
Oh, your mobile phone? Oh, this
yeah.
would have been like the Blackberries. This would have been BlackBerry was one. This was still a smartphone. It was still a smartphone. It was still a phone that could do both voice and data. But the data was not predominant now. It was getting more and more people were using it for data. But this would have been like, BlackBerry was one. There was an early Android versions back then. But this is pre-iPhone. The iPhone is what really made data basically explode. Once people got the iPhone, they were using their data. They're using their phone for data. But this is still before then. So people are using for data, just not. Again, no video, no things like that. This network couldn't handle downloading a video. It could take you hours to download a video. But there was data here.
Okay, very well. Okay, so
David. Oh, I'm sorry. Yes.
Yeah, David. If you can go on.
Okay.
Yeah.
Yeah. So my question is, when you buy a phone, right? Maybe a 4G phone. It's written on it 4G. So you buy the phone and you go online, and you see a status symbol at the top showing that your network is 4G. But then it goes back to 3G, and even sometimes it goes to H. So I want to know what generation is it? Is it going back to the third generation when it goes to 3G?
Yes.
And
what
generation is the H?
You would go back to a 2G or a 3G.
Yes.
But you have to have, the network has to have both of those. I'm going to go ahead a couple slides. I'm going to go ahead, just bear with me here. I'm going to go ahead. You need this right here. Fourth generation, and we're going to talk about this on Friday. Fourth generation is data only. There's no SMS. There's no circuit type services. Fourth generation is data only. So when you need your phone for voice, how do you do it? Two ways. One way is right here. Circuit switch fallback. You go from your fourth generation, you have this connection back to the 2G, 3G network. And then this cell tower will command the mobile to retune to here for voice services. That's one way. The second way is something called voice over LTE. Voice over LTE, where this thing is what's known as a SIP phone, session initiation protocol, and it carries the SIP signaling through these data tunnels into this network called the IMS, the IP Multimedia Subsystem. So to answer your question, yes, if you have a 4G phone and you go into a rural area or some area of town that is only 3G, as long as that network has maintained its 2G, 3G network, and you go from 4G, you can go to 3G. Or if you need to use your phone for 3G services, because once you get to 4G and 5G and any other G beyond 3G, by the time you get to 4G, 4G is this. 4G is data only. So you need to do other things to handle circuits. 4G only handles data. To answer your question, no, we'll go into that in more detail Friday.
Yeah.
Okay.
I think you talked about the age.
Did that answer, David? Did that answer your question though?
Yes, that's giving me a general view.
Yeah, good.
But you talked about the age, which the age class. Yeah, mostly on some phones you are going to see H plus. Is that connected to any generation?
I didn't understand the H class.
H plus.
Oh, like high speed access, you mean?
Okay, is that a 4G whenever you see a H plus?
When you see an H plus, I'm not sure. I don't see that on my phones here. Okay. I don't see, like, you mean like the letter H and then a plus on it?
Yes. Mostly I do see.
Yeah, I'll have to take a. I don't see that here, so I'm gonna have to look at that.
Okay.
I'll see if I can find out if there's from the specifications what that is. I'm not familiar with that.
Okay.
H plus, maybe high speed packet access, high speed access, something like that. That could be. Not sure. I'm not sure. I don't want to comment unless unless I know. Anything else?
Yeah. So.
Yeah, David.
David, did we get it answered?
Yeah, I think that's about it.
Okay. So we'll bring this session to an end if there is no more question. Thank you guys, and thank you, Steve, as well. Yes.
Okay, let me, I'm gonna move you now over back to here. Once I move you back to here, now I gotta get rid of the infinity here. Let's see, let's stop sharing. There we go. That's better. Close my chat window. All right.
Okay, so Eulalia, you can proceed, right? I think you have something. Or it's just by mistake, Eulalia.
Oh, okay. Please, I want to say that I tried reading the slides all over again, and I realized that I had like a lot of questions, and that would take us like back again. So I was asking if it's possible that we recap the topics we've treated so far to be sure we've gotten the concept.
So you mean like a recap?
Please, that's my question.
Okay, so I'm not sure about a recap because
Yes.
of the timeline of the program, essentially. But in any question that you have, I think you can ask Steve through the platform, the WhatsApp platform. It's very quick. If not, to Gmail would be very good as well. But Steve, is there any remarks you want to give on that?
Well, we can do a recap. We're probably not going to finish up on Friday because we've still got some material to do. We got to get through third and fourth generation and just kind of the concepts of. Well, when is this particular class ending now? When are they going to go on after the first of the year?
Okay, so from the networking instructor, he's completing with them this week. So by Saturday they should be ending the class for this one.
Okay.
Yeah.
So this particular class has to end Friday.
Yeah, this kind.
Okay.
But I suppose we can go a little further for them in the telecom because of the limited amount of time we have. So we can include next week to it as well.
If we have to, yeah, maybe we could devote like an hour next week on Monday or Tuesday or someday next week. We can maybe devote some time, and then I can do a recap, and we can just open it up for general questions.
Yes. Okay.
Okay.
I hope you guys are
well,
on board with that.
Hope that works. If that works out, we can certainly do that. Yeah.
Yeah.
And
Okay.
if people can't physically come to the building, maybe they can just access from their computer, their home, their phone, or something like that too. If it's a problem getting to this location where you're at, I don't know.
Okay, good. Okay, so thumbs up if that works for you. Like,
okay,
if you agree.
excellent.
Okay,
And
right.
we'll Raphael and I will talk about that now. So I want to thank you all very much. Thank you
Thank you
for listening to me, and yeah, very good. And